Welcome to chemistry classes. In this video, we are going to discuss about classification of elements. Grade 11 Chemistry Chapter 3 Classification of elements and periodicity in their properties. Okay, so here in this chapter we have to discuss here development of periodic table. We will discuss development of periodic table, periodic law, Mendeleev periodic law, modern periodic law. Also we will discuss here periodic classification of elements, periodic classification of elements and electronic configuration. Also we have to discuss here physical and chemical properties of elements, physical and chemical properties of element. Okay, so here first point we have to discuss here, why do we need to classify element? Why do we need to classify element? Why we need a classification of element? Here we know elements. Elements are the basic building unit of matter. Elements are the basic building unit of matter. Elements are the substance, it contains only one type of atoms. Elements are the substance, it contains only one type of atom, that is elements. Okay. Also here there are more than 118 elements in modern periodic table. More than 118 elements. Okay, and it is hard to study properties of individual elements. It is hard to study properties of individual elements. That's why we will classify these elements according to their properties. We will make them a group according to their properties, and we can study their properties easily. Okay, next one we have to discuss here genesis of periodic classification, origin of periodic classification. There are many scientists did many work, they did experiment and observation to classify elements. Okay, here first we have to understand the important word Johann Dobereiner, he is the scientist first observed trend in properties of elements. Trend in properties of elements first observed by Johann Dobereiner. And this scientist Dobereiner, he introduced law of triads. Law of triads. Triads. The term triads introduced by Dobereiner. Okay. Law of triads. Okay, triads mean a group of three elements, several groups of three elements. That is triads. Okay, this is one triad, this is another triad. Here three different triads are given. Triads mean group of three elements. Okay, here lithium, sodium, potassium, this is one triad. Here we have to understand the middle element. This middle element, atomic weight of this middle element will be average atomic weight of other two. Here three element. Okay, atomic weight of this element will be average atomic weight of other two. Example, see here atomic weight of sodium, it is 23. Okay, it will be average atomic weight of other two, means 39 plus 7 divided by 2, it will be 23. Okay, similarly here atomic weight of strontium, also there will be a relation like that, 40 plus 137 divided by 2, it will be 188. Exactly 88 or almost 88. Okay, some case it will be almost similar. Okay, so here also the middle element, atomic weight of middle element will be average atomic weight of other two element. Also their physical and chemical properties of middle element, also average of other two element. That is law of triad. Okay, so here according to law of triad, the middle element of each triad had an atomic weight about halfway between atomic weight of other two. Okay, its mean atomic weight of middle element will be average atomic weight of other two. Also, the properties of middle element will be average of other two. For example, potassium, it is highly reactive. Okay, lithium comparatively less reactive. So sodium will be average or middle of these two, not highly reactive, not unreactive, between lithium and potassium. So atomic weight, it is like average between potassium and lithium. Also its properties also coming middle of this two element. Okay, this is triad. So law of triad introduced by Dobereiner. Okay, triads means several groups of three elements. Clear? So here you understand atomic weight of middle element, average atomic weight of other two elements. Also properties of middle element will be between other two elements. Clear? So here we discuss law of triad. Law of triad applicable only for few elements. It's not applicable for all elements. Okay, it is not applicable for all elements. It's applicable for only few elements. That's why law of triad failed. After that, another law we have to discuss here. Another law introduced by John Alexander Newlands. Okay, this is new chemist. He introduced another law. It is called law of octaves. Okay, octaves. Okay, octaves mean eighth. Okay, law of octaves. Law of octaves. Here we have to understand. Here Newlands arranged the elements according to their atomic weight. There are different type of elements that time, and he arranged the elements according to their atomic weight. Okay, when he arranged the elements according to their atomic weight, he noted that every eighth element had similar property to first element. Every eighth element had similar property to the first element. Okay, so imagine Newland arranged the elements according to their atomic weight. Okay, 1 2 3 4 5 6 7 8. Then so here this is first element and this is eighth element. This eighth element has similar property to first element. Okay, then next eighth element. So next eighth element has similar property to the first element. Okay, this is law of octave. So law of octave introduced by John Alexander Newlands. Okay, and Newlands arranged the elements according to their atomic weight. Okay, atomic weight. When he arranged the elements according to their atomic weight, every eighth element shows similar property to the first element. Okay, just like every eighth note that resemble to the first octave of music. Okay, music. Sari gama pada nisa. So here every eighth note that resemble to the every eighth note that resemble to the first in octave of music. Okay, similar things observed here. That's why this law called law of octaves. Also this law of octaves also not success. It is applicable up to calcium. Okay, we know calcium atomic number 40. Okay, so here this is the 20th element. Okay, so this law only applicable from first to 20 element only. Also it is not applicable for all elements. That's why law of octave also failed. Clear. So here we discuss law of octave. Law of octave introduced by Alexander Newlands. Okay, Newlands arranged the elements according to their atomic weight. Every eighth element shows similar property to the first element. Okay. Next one, we have to understand here periodic law. Periodic law introduced by two different scientists. He is Dmitry Mendeleev and Lothar Meyer. Dmitry Mendeleev, he is Russian chemist, and Lothar Meyer, he is German chemist. Russian chemist and German chemist. They worked independently, not together. They worked independently and they came to periodic law. Both of them arranged the elements according to their atomic weight. Okay, both Dmitry Mendeleev and German chemist Lothar Meyer, they introduced periodic law. Okay, they worked independently. Okay, they arranged the elements according to their atomic weight. They arranged the elements according to atomic weight, and they observed elements with similar physical and chemical properties appeared in regular interval. Elements with similar physical and chemical property appeared in regular interval. Okay. Also here Lothar Meyer did another work. Lothar Meyer, he plotted a graph, physical properties of elements such as volume, melting point and boiling point against atomic weight. Lothar Meyer, he plotted a graph. Physical properties of elements such as melting point, boiling point, volume against atomic weight. Okay. Also, when he plotted such type of graph, he observed a periodically repeated pattern. Elements with similar properties repeating in regular interval. Okay. Okay, next one we have to discuss here Mendeleev Periodic Law. Mendeleev Periodic Law. Okay, so here before we discuss periodic law introduced by Lothar Meyer and Mendeleev, but Mendeleev published it first. Okay, Mendeleev published periodic law first. Here Mendeleev arranged the elements according to their atomic weight. Okay, so here Mendeleev periodic law state that properties of elements are periodic function of their atomic weight. Okay, properties of elements are periodic function of their atomic weight. This is Mendeleev periodic law. So you remember there is Mendeleev periodic law, also modern periodic law. So both are different. So Mendeleev periodic law, he arranged the elements according to their atomic weight. So here Mendeleev periodic law, properties of elements are periodic functions of their atomic weight. Remember that. In modern periodic law it is different. Clear? So Mendeleev arranged the elements. He arranged the elements in horizontal rows and vertical column. According to their atomic weight. When he arranged the elements in horizontal rows and vertical column, he observed that elements with similar properties came in same vertical column. Okay, elements with the same properties, same physical and chemical properties came in regular interval. Okay, elements with the same properties occupied in same vertical column, or you can say group. Clear? Also, Mendeleev found that similarity. He found some similarity in empirical formula of compound. Also properties of compounds formed by different elements. Different elements formed compound. Okay, so he found some similarity in their empirical formula. Also, he found some similarity in properties of compound. Okay, properties of compounds formed by elements. So he arranged the elements according to their atomic weight. So he observed elements with the same properties came in same vertical column. Also he found some similarity in empirical formula of the compound, also properties of the compounds formed by elements. Clear? Okay, so here we discuss Mendeleev periodic table. Mendeleev arranged the elements according to their atomic weight. He arranged the elements in rows and columns. Okay, so here another important work of Mendeleev. He predicted that some elements were not discovered. Mendeleev said at that time, some elements are not discovered, it will discover future. Also, he put some gaps in his periodic table. Example, at that time, gallium and germanium were not discovered, and he put some he put some gaps after aluminium and silicon for that elements. Mendeleev predicted some elements are not discovered and he put some gaps for that elements to discover. Also, he predicted the physical and chemical properties of the elements to discover in future. This is very important point in Mendeleev periodic table. Here in Mendeleev time, gallium and germanium were not discovered and he put some gaps for that element, and he called that elements Eka aluminium and Eka silicon. Mendeleev time there is no gallium and germanium, but he predicted there will be an element after aluminium and he called it is Eka aluminium. After silicon there is another element, it is he called it is Eka silicon. Also he predicted its physical and chemical properties. Okay, Eka aluminium and Eka silicon. So these are the important points we had to understand in Mendeleev periodic table or Mendeleev periodic law. Clear? Okay, next one we have to understand here modern periodic law. Modern periodic law and present form of periodic table. Okay, here first we have to understand the work of Henry Moseley. We have to understand here Henry Moseley. He did one experiment. He did study in characteristic study of X-ray spectra of element. He did characteristic study of X-ray spectra of elements. He passed non-frequency of X-ray through different elements. Okay, and he got some data and he plotted a graph. Frequency root of nu versus atomic weight. He plotted a graph frequency of X-ray, root of frequency of X-ray against atomic number, and he got a straight line. So here we are studying Henry Moseley. He did characteristic study of X-ray spectra. He passed the non-frequency of X-ray through different elements. Okay, then he got some information. From this information he plot a graph root of frequency of X-ray against atomic number. He plotted a graph root nu against atomic number. Remember this, root nu against atomic number, and it was a straight line. Okay, same time he plotted root nu against atomic weight. It was not straight line. Okay, against atomic number it was straight line, and against atomic weight it is not straight line. So from this he concluded that the fundamental properties of elements are based on their atomic number, not atomic weight. Okay, from his study he concluded that the fundamental properties of elements are based on their atomic number, not atomic weight. Clear. So based on this, here now Henry Moseley proved that the properties of elements are based on their atomic number, not based on atomic weight. That's why here Mendeleev's periodic law modified. Mendeleev saying the periodic functions, the properties of elements are based on their atomic weight. So it was modified by Henry Moseley. Okay, so his study was he passed X-ray through different elements and he plotted graph root nu against atomic number. Okay, next one we have to discuss here modern periodic law. We discuss Mendeleev periodic law, periodic functions of physical and chemical properties of elements are periodic functions of their atomic weight. That is Mendeleev periodic law. Next one we have to discuss here modern periodic law. According to modern periodic law, physical and chemical properties of elements are periodic functions of their atomic number. Here the difference, atomic number. This is modern periodic law. Okay, physical and chemical properties of elements are periodic functions of their atomic number. Okay. Look here, this is atomic number. Nowadays we know atomic number is very important for a particular element. Atomic number called ID proof of an element. Atomic number, that is ID proof of an element, because you know many things depends on atomic number. Atomic number equal to nuclear charge. Atomic number will be equal to nuclear charge. Nuclear charge means number of proton. Inside nucleus there is neutron and proton. Okay, so atomic number equal to nuclear charge because atomic number equal to number of proton. Okay, atomic number also called proton number. Clear. Also atomic number equal to number of electron. Atomic number generally, not in ions, neutral atom, atomic number equal to number of electron. Okay, using number of electron we can write subshell electronic configuration. Subshell electronic configuration. Outer shell electronic configuration or outer shell electrons depends on valency. Outer shell electron depends on valency. Okay, so using valency we can predict physical and chemical properties of elements. Clear. So that's why these things are indicate that atomic number is very important for an element. Atomic number equal to nuclear charge. Atomic number gives number of electron. Using number of electrons we can write down subshell electronic configuration or electronic configuration. Using outer shell electrons we can say valency. Using valency we can predict physical and chemical properties of elements. Clear? Look here in modern periodic table also called long form periodic table. Okay, modern periodic table also called long form periodic table. Long form periodic table. In periodic table there is horizontal rows and vertical column. Okay, horizontal rows mean this type of column. Horizontal rows are called periods. Okay, vertical column, this type of column, vertical columns are called group. Horizontal rows and vertical column. Horizontal rows are called period, vertical columns are called group. Clear? So elements with the same outer shell electronic configurations are coming in same group. In modern periodic table, elements with the same outer shell electronic configuration, it will be in same group. Okay, for example lithium, lithium, sodium. Lithium outer shell electronic configuration 1s2 2s1. Sodium also 1s2 2s2 2p6 3s1. So atoms with the same outer shell electronic configuration, it will be in same group. Okay, so see here S1. So all S1 will be in same group. Clear? Okay, so here last part of this video we have to discuss here. In modern periodic table you can see here 18 group. 18 groups are there in modern periodic table. Group 1 to group 18. Okay, so there are 18 groups in modern periodic table. Also there are 7 periods in modern periodic table. Okay, 7 period and 18 group. Okay, so here in first period there are two elements. In first period there are two elements. Okay, also we have to study more details about different groups, and we have to discuss lanthanides, actinides. We will discuss next video. Okay, so thank you for watching this video.